Hello, everyone. Um, when you say engineer of the future, this is what some people picture. Virtual reality, augmented reality, holograms. It's scary for some, and it's quite exciting for others, like me. Some people take it one step further and imagine something like this. Now, this is truly changing the face of the engineer. In June last year, Balfour published a paper called Innovation 2050, where it predicted that construction sites would be human-free in 2050. But right now, engineers look a little bit less like this. They look a little bit more like me. So how do we make that change? So my name is Tina Gunnersson. I'm a senior temporary works engineer at Balfour Beatty. And over the last 6 months, I've led a team of 14 people, ranging from apprentices up to director level, trying to figure out how we make our engineers fit for the future. So 2050 is a long time away, and we started by narrowing our scope. We tried to identify the skills, knowledge, and behaviors required of engineers in just 5 years' time. We started off with a rigorous literature review. We reviewed papers from Forbes, the World Economic Forum, down to industry-specific papers by the CITB, down to in-house research on digital in highways by Christian Jackson, a paper on creativity in the curriculum by Professor Perry Shard. We then launched engagement sessions, we held workshops, we ran a Yammer campaign, and we surveyed our entire engineering population to see what they would think. And the power of data, as already shown, is astonishing. So it turns out that the top future engineering competency is going to be engineering knowledge and understanding. Who would have thought? So engineers of the future need to be good at engineering. We took this as a sign, not that we need engineering skills in the future, but that we need engineering skills right now. So the skills gap, we've got 700,000 engineers set to retire in the next 10 years. I think this is a key indicator that shows that we need to start working on that right now. And we don't mean theoretical engineering, we mean practical engineering, like knowing that plywood comes in set sizes, and sometimes it makes sense to design to 488 instead of 500 millimeters. Or maybe that you shouldn't anchor your scaffold to the building that you're demolishing. I recently listened to a talk by Olympic coach Dan Hunt, and he said to train Olympic-level professional cyclists, you don't start with the aerodynamic helmets, you don't start with the wind tunnels. All of that is the cherry on top of the icing, on top of the cake. You need to start with your basics: sleeping, eating, cycling, or in our case, engineering. So how do we get our engineers a good, solid, robust engineering education? Most employers would send their engineers on training courses. But how many people have attended a training course that looks a little bit like this by the afternoon? This is not how we educate engineers for the future. In Balfour Beatty, we're trying to implement the 70-20-10 model. 70% of your learning to come through on-the-job experience, through job rotations. 20% through informal learning and mentoring, and 10% through formal learning in the form of blended learning. The second skill we established an engineer of the future is going to need is digital integration. And that's using digital tools to support that robust engineering foundation. Engineers are going to be increasingly more data savvy, and we're going to see this more and more. We've already touched upon the power of data. We're seeing an increase in 3D modeling, and 4D is coming soon with time, and 5D with cost. We've got a digital twin up and running on the M20. AR and VR, augmented reality and virtual reality, is becoming more and more commonplace at inductions, at training, for problem solving. This is where we start to see the robot and the human world merging. Exoskeletons are already being trialed to help heavy lifting, and there's a trial robot engineer down on the M6 doing a bit of setting out. So suddenly that dream of 2050 doesn't seem that far away. A successful joint venture on the A14 tested autonomous trucks, and these are just a few of the many, many more examples that you are bound to see over the next 2 days. The third and final skill that we identified was critical problem solving and creative thinking. Now this is really interesting. How do you train someone in critical problem solving? Engineers in the future, and right now, are facing the really big climate change questions. So we need to give them the tools to be able to find solutions to these problems. One way of doing that is through simulation centers. So we're currently trialing one up in Coventry. It's an immersive scenario using actors that really hones in on teamwork, collaboration, and emotional intelligence. The other way that you could increase creativity and problem solving is through diversity, through introducing cognitive diversity. One successful scheme we've run in Balfour Beatty is reverse mentoring. This is where a junior member of staff mentors a senior leader in the business. Up on the screen is one example. I've been involved in the scheme for 2 years. Our highways scheme just launched 2 weeks ago, and all of our executive committee are being reverse mentored. So I want you all to just take a moment to appreciate that the CEO of Balfour Beatty, Leo Quinn, responsible for £7.8 billion of turnover each year, is being reverse mentored by a female apprentice from our multicultural network. We recently held our second Inspiring Women's Conference, and from that we developed 4 work streams to focus on. These are site culture, flexible working, parental leave, and inspiring talent. Some of the leads are here today, if you happen to speak to them or run into them. Now, this is focusing on gender, but no doubt the benefit of that will bleed into all of our other affinity networks, including our multicultural network, our LGBTQ+ network, and our disability, or as we call it, ability network. And although construction has a long way to go, we are becoming a lot better at celebrating and recognizing the importance of diversity. So all of these findings are being written up in a paper aptly titled The Engineer of the Future. So I guess just to summarize, our vision for the future, 5 years' time, is a diverse and a dynamic team that are working together. They're utilizing digital tools to empower them, help them with their creative problem solving, and all of that is founded in a really robust engineering foundation.